The spindle just stopped. The CNC is still moving, and the VFD is flashing ERR 38. Should I reset it and try again?
No, stop the machine, take a picture of the code, and step away from the reset button.
Even if turning it off and back on is my most developed technical skill?
Especially then. That error code is a clue, and resetting the VFD before you look at the evidence can turn a useful clue into an expensive guessing game.
Today, we're learning how to read those clues without making the problem worse.
Welcome to the CNC Workshop, presented by Pone CNC. I'm Daniel.
And I'm Jamie. We're talking about one of the least comforting things a CNC owner can see. The spindle suddenly stops, the machine may still be moving, and the VFD is staring back at you with an angry little error code.
Exactly. ERR09, ERR12, ERR31, ERR38. It looks like the VFD has given you the answer, but it has really only given you a clue.
So the error code is not the diagnosis?
Right. That is the big idea for this episode. A VFD error code is a starting point. You still need to consider what the machine was doing, when the fault occurred, whether the spindle was under load, whether an axis was moving, and what condition the cable and connectors are in.
In other words, the machine says, something is wrong, and then leaves us to conduct the investigation.
Pretty much. But the code narrows the investigation, and that can save a lot of time if we use it correctly.
Before we get into the individual errors, give us the quick version. What is the VFD actually doing when it throws a fault?
The VFD controls the power going to the spindle motor. It is constantly watching electrical conditions such as current, voltage, and the balance of its output phases. When it detects something it cannot safely ignore, it may shut down to protect the VFD, the spindle, or both.
So an error is annoying, but the VFD may be the only adult in the room at that moment.
That's a fair way to put it. The worst response is to keep resetting it and forcing the job to continue without finding out why it stopped.
Especially because the spindle can stop while the CNC controller keeps moving.
Yes, and that is an important safety issue. The controller and the VFD are separate parts of the system. If the VFD faults, the controller may not automatically know the spindle has stopped. It can continue driving a stationary cutter through the material. That can break the tool, damage the workpiece, damage the spindle, or put a lot of force into the machine.
So if the spindle stops during a cut, stop the machine. Don't just clear the error and hit resume.
Correct. Stop the job, record the exact error, and look at what happened. Before inspecting spindle wiring, disconnect power from the VFD and allow it to discharge according to its manual. And don't open an enclosure or touch electrical terminals unless you're qualified to work around that voltage.
Good. Let's start with ERR09 because this one sounds serious. Frequency inverter overloaded.
It sounds like the VFD is ruined, but ERR09 often means the cutting operation asked for more than the spindle could maintain. It generally indicates a sustained overload.
What can create that overload?
A feed rate that is too high, too much depth of cut, full width slotting, an aggressive ramp, a heavy chip load, poor chip evacuation, or a dull tool. A bound collet or spindle can contribute. So can inadequate work holding or a flexible machine that allows the cutter to chatter and load unpredictably.
I imagine tool size matters too.
Absolutely. A large cutter removing material at full width and full depth can demand a lot from the spindle. And one thing people sometimes miss is spindle speed. A spindle may have less usable power when it is operating well below its rated speed. Running slowly does not automatically make a heavy cut safer.
That feels backwards if someone is coming from a hand router. They may think, I'll slow it down and take a big bite.
Right. But you need to balance RPM, feed rate, chip load, tool diameter, flute count, depth of cut, and step over. Those values work as a system.
So ERR09 appears halfway through a deep slot. What should I do first?
Review the cutting parameters before buying any hardware. Record the tool diameter, flute count, RPM, feed rate, depth of cut, step over, and whether the tool was cutting at full width. Look at how the tool entered the material and whether chips were clearing.
Then make the cut easier?
In a controlled way, try a lower feed rate, a shallower depth of cut, less step over, or a more gradual ramp. Don't change 6 things randomly and then wonder which one mattered. If reducing the load makes ERR09 disappear, the original tool path probably exceeded the available spindle torque.
But if ERR09 happens during a light finishing pass?
Then it deserves a closer look. The same is true if it happens while the spindle is running without cutting. An overload code with no meaningful load can point toward a mechanical problem, a cable or connection issue, an incorrect setup, or a problem inside the spindle, or VFD.
So ERR09 is often the machine saying, that was too much cut, but not always.
Exactly. Context decides whether that explanation makes sense.
Next is ERR12, output fault or 3-phase imbalance. What does that mean in plain English?
The VFD sends 3 output phases to the spindle motor. ERR12 generally means it detected an output problem or an imbalance among those phases. On a CNC system, an intermittent spindle power connection is one of the first things I would consider.
Such as a loose connector?
Yes, a loose spindle connector, a damaged cable, a poor connection at the VFD output, or a cable that has been pinched or repeatedly bent too tightly. Strain near the spindle connector is another common place to inspect.
This is where the timing of the error becomes really useful, isn't it?
Very useful. Suppose the spindle completes its warm-up while the machine is stationary, but ERR12 appears when the gantry begins moving. That strongly suggests inspecting the moving cable system before changing VFD parameters.
Because the cable flexes when the machine moves.
Exactly. We've seen an installation where the spindle ran normally until machine movement caused ERR12. The power cable was packed into a drag chain with too little room and too tight a bend. Removing the cable from the chain stopped the error. Putting it back caused the error to return. A larger chain and a more generous bend radius resolved it.
That is a beautifully annoying troubleshooting result.
It is, because the cable can look fine from the outside. A cable may technically fit inside a drag chain and still be routed badly. If the chain is crowded with spindle power, coolant tubing, control wires, and air lines, the cable can be crushed or forced into a bend it was never designed to make.
What should someone inspect for ERR12 after everything is safely powered down?
Inspect the entire spindle cable, especially where it enters and leaves the drag chain. Look for tight bends, pinch points, abrasion, crushing, or strain. Check the spindle side connector and the VFD side connector. If you are qualified to inspect the internal connections, look for loose output terminals and confirm the ground and shield connections are correct.
And if it only faults when the machine moves, do not begin by rewriting every parameter in the VFD.
Correct. Follow the physical clue first. Random parameter changes can add a new problem on top of the original one.
Before we move into the next set of faults, the CNC Workshop is presented by Pone CNC.
Pone CNC builds spindle systems, VFD packages, automatic tool changing systems, and CNC controller upgrades. We also maintain a growing technical knowledge base to help CNC owners understand, install, and troubleshoot their equipment. You can find the companion article for this episode, along with additional VFD troubleshooting resources, at ponecnc.com.
All right, back to our collection of angry little error codes. Let's move to ERR31, which may also appear as 031. The article calls this a current detection fault. How is that different from ERR09?
ERR09 generally points toward a sustained operating overload. ERR31 is more closely associated with the VFD's current detection circuitry or related electrical conditions. It can indicate an internal VFD problem, although cable damage, grounding problems, loose or overheated connections, electrical noise, or a problem inside the spindle can also be involved.
So ERR31 is the one where we should be careful not to say, I must have pushed the cutter too hard.
Exactly, especially if the error occurs during a light finishing operation or while the spindle is not meaningfully loaded. If the cut should require very little power and the VFD still reports a current detection fault, cutting parameters become a less convincing explanation.
What observations should we write down?
Note whether ERR31 appears immediately after starting, only after the spindle warms up, only while cutting, only while the machine moves, or during both loaded and unloaded operation. Those details help separate a thermal or internal fault from a movement-related cable issue or a cutting load problem.
And the physical inspection?
With the system safely powered down, inspect the spindle cable and both connectors. Look at the VFD output connections if you are qualified to do so. Check the spindle and VFD grounding. Look for signs of heat, arcing, discoloration, or burnt insulation. With power removed, confirm that the spindle rotates smoothly by hand and does not feel rough or bound. Stop when the same error returns after the basic inspection, especially if the spindle stops during active cutting. Stop if the cable shows heat, crushing, abrasion, or connector damage. Stop if you smell burnt insulation or electronics, if the spindle becomes unusually hot, or if it develops vibration or roughness.
ERR31 during a light or unloaded operation would be another stop sign.
Yes, as would ERR38, returning after power cycling, a blank display despite confirmed input power, or a CNC controller that continues moving after the spindle stops. Those conditions deserve a careful evaluation rather than another attempt at the job.
Let's talk about contacting support, because there is a huge difference between my spindle stopped, help, and a useful troubleshooting report.
There really is. The fastest support usually begins with complete information. Start with the error code exactly as displayed. A photo is helpful because ERR3, 1, and 031 can be easy to describe differently.
What system information should be included?
The CNC machine brand and model, the controller brand and model, and the spindle's power, voltage, and cooling type. Include the approximate age of the spindle system and the original order number if you have it.
Then explain the conditions when it failed.
Right. Did it happen while cutting or while running unloaded? What RPM, feed rate, depth of cut, tool, and step over were being used? Was the cut full width? Did the error occur when the machine moved? Did it happen immediately, after warm-up, or after an hour of use?
And photos.
Photos of both spindle cable connectors, the VFD enclosure and connections, the model label, and any damaged cable or connector. A short video showing the fault can be useful if the condition can be reproduced safely. Do not recreate a dangerous short or keep running a damaged cable just to make a video.
This is also where older order information matters because systems change over time.
Exactly. Connector styles, VFD enclosures, cable options, and spindle configurations can change. A clear photo and the original order number help support identify what you actually have before recommending a replacement cable, VFD, or motor.
Let me try to build the whole troubleshooting method in one example. I'm cutting a deep full-width slot with a large bit. The VFD shows ERR09. I stop the machine, photograph the code, record my cutting parameters, and perform a controlled test with a shallower cut.
Good. If the lighter operation works normally, that is strong evidence that the original cut exceeded the available torque.
Second example. The spindle warms up without an error, but ERR12 appears as soon as the gantry travels to the far end of the machine.
Inspect the moving spindle cable, drag chain capacity, bend radius, and connectors before changing parameters.
Third example. ERR31 returns while the spindle is running unloaded.
Stop repeatedly resetting it. Inspect the cable, grounding, connections, and spindle condition Then arrange for the VFD or system to be evaluated.
Fourth example, ERR 38 appeared after a coolant leak near the spindle connector.
Disconnect power, allow the VFD to discharge, and inspect for moisture or contamination. Do not keep testing the spindle. That is a possible output phase short, not a maybe it'll dry while cutting situation.
Fifth example, no error code, but the spindle starts from the VFD keypad and not from G-code.
Investigate controller configuration, control cable, VFD control mode, and the G-code command. That sounds more like a control path problem than a failed spindle motor.
I think the pattern is clear now. The code matters, but the most useful question is, what was happening at the exact moment the code appeared?
Yes. Combine the code with the timing, cutting load, machine movement, cable condition, and unloaded behavior. That combination is much more reliable than the code alone.
And please resist the urge to solve every electrical problem by changing a parameter you found in a forum post from 2017.
Especially when it was written for a completely different VFD. Record the original settings, use the correct manual, and change only what the documentation for your controller and VFD requires.
Daniel, if listeners remember just 3 things from this episode, what should they be?
First, an error code is a clue, not a complete diagnosis. Second, if the spindle stops during a cut, stop the CNC and do not repeatedly reset the VFD. Third, preserve the evidence, photograph the display, record what the machine was doing, and inspect the system safely before anything gets rebooted or changed.
That alone should prevent a lot of damaged tools, mystery replacement parts, and support emails that begin with, "It did a thing."
It really would. The goal is not for every CNC owner to become a VFD repair technician. The goal is to recognize the type of problem, perform safe first checks, and provide enough information for the next step to be accurate.
The complete companion article includes the written quick reference and the list of information to collect before contacting support. You can find it through ponecnc.com.
And if you need help identifying the appropriate replacement, VFD, spindle cable, or spindle motor, send Pone CNC clear photos of the system and the original order information before purchasing parts.
The CNC Workshop is presented by Pone CNC. Thanks for listening.
Until next time, pay attention to the clues.
And make some chips, preferably with the spindle still spinning.